Hello, this is Patryk Radyjowski, an R&D Engineer at Advanced Cooling Technologies, and in this video I will be telling you more about our neutron vacuum furnace cooling technology. In the last video I introduced what the neutron vacuum furnace is and just basics of how we cool it. In this video we're going to look more into what's happening. So first let me tell you more about the system itself. So we have our proprietary nozzle system that distributes the incoming cooling gas throughout the furnace. And then once the hot gas heats up and it's ready to be cooled down, it exits the furnace and goes to our external compact support card. When we filter it, cool it down. Also we monitor if we picked up any oxygen, because if you have oxygen hot parts, you will have oxidation damage. So that's also we're monitoring in our card. And when we're happy with the gas that is already ready to go back, it continues back to the furnace. And this is a closed loop circulation, so we're not losing any gas. That means we can use some of the more expensive one, like high performance helium. That is currently quite expensive, although necessary for neutron experiments. So having the tight control over what we circulate, at what pressure and at what speed, allows us to do a lot of cool things. So let's go back to my favorite temperature plots, and where I will tell you more what we can achieve with our system. So first, let's plot temperature, capital T versus time. Now if everything's going to be closer to minutes, and this is going to be degrees Celsius. And first, for reference, if we cool with just the vacuum, it's going to be a long, slow line, and it can go to about 300 minutes. Very long time. So first, we can control the flow rate of the gas. So for one extreme, when the gas is stagnant, we already learned that it already helps a lot. So for example, for helium, there's going to be this line, which is about 40 minutes. And then what we learned is that if without our gas distribution system, even if we start circulate, a lot of times the improvement from the gas circulation will be very close to just stagnant gas. Stagnant. But what we demonstrated that our system at the low flow rates, we already can get some improvement, something closer to about 20 minutes. And on the high flow rate, something like 1 to 2 grams per second of helium, for example, which by the way is quite challenging to do it at low pressures, we can go as little as our best results are about 5 to 10 minutes. So this is major improvement. And not only that, if we want to go slower, we can both use partial pressure for the stagnant as well as use other gases, like for example, more economic nitrogen, which again is going to have its own set of line from stagnant with some amount of improvement as you start circulating at different speeds. And what it means for us, we can cover the full range of times you might be interested. So that is one way we can operate. But not only that, our support card has a high degree of autonomy, and it can do very smart things. One of which it can modulate its flow speed such that in special cases when we actually we're not only aiming at the time, some scientific experiments actually ask us to have a very strained, constant cooling rate. So by modulating the speed of our gas circulation, we've shown that we can start and have nearly constant cooling rates. And that's what made scientists very excited. So we can do something like 10 degrees Celsius per minute, all the way, what I remember, is about 50 degrees Celsius per minute currently, and we're still working to make it better. Those are only some of the capabilities. We're still working to make it even better. But if you want to learn more, check our website and get in touch with us. I would love to talk with you more about this technology.